Hello, friend, and welcome to the Sleepy Meteorologist. Tonight, we're stepping into the quiet wonder of falling snow. Those soft, silent flakes that turn the world into a hushed, glimmering dream. As the evening deepens and the air turns cool, let this be your gentle retreat into calm. Snow doesn't rush, it drifts, it dances, it hushes the landscape beneath a blanket of light. And in that stillness, something peaceful happens, inside and out. Maybe your day has been full, or maybe you've just been waiting for something soft to carry you into sleep. Either way, you're safe here. There's nothing you need to do now except rest. How's the night feeling where you are? Can you hear the quiet? If you enjoy these gentle weather journeys, you're warmly welcome to subscribe, but only if it feels light and easy. No pressure, just presence. For now, let your breath slow. Let your shoulders drop. Let the cold stay outside while the warmth settles in. You are wrapped in quiet, surrounded by softness, and ready to drift. Let's begin. Every snowfall begins not with a storm or a swirl or even a sound, but with a single, silent flake. It's almost too gentle to notice. One moment, the sky is still, and the next, something small and white drifts past a window pane or lands delicately on the sleeve of a coat. This chapter is a quiet tribute to that very first snowflake, the one that begins it all. Before it can fall, the atmosphere must come into a special kind of balance. High above the ground, in the chilly reaches of the troposphere, invisible currents of air carry water vapor to places where the temperature hovers below freezing. But cold air alone isn't enough to summon snow. Something else is needed, something tiny, a seed. These seeds are not made of soil, but of microscopic particles, bits of dust, salt, or even pollen that float through the sky. In meteorology, we call them ice nuclei. These minute particles serve as the starting point for snowflakes to form. They offer a surface for water vapor to cling to, and more importantly, to freeze upon. As water vapor in the air touches these particles, it transforms, changing directly from gas into solid ice in a process called deposition. And from this quiet transformation, the first snow crystal is born. Up here, where the winds whisper and the air is thin, temperature plays the role of sculptor. If the conditions are just right, arms of ice begin to extend outward, forming the earliest points of what will become a snowflake. The colder the air, the faster the growth. The more humid the surroundings, the more intricate the design. But in this first moment, all of that still lies ahead. For now, it's only the beginning. A single flake, light as breath, starting its descent through layers of sky. Its fall is not hurried. Snowflakes drift, often slower than a feather. They sway and wobble as they pass through different pockets of air, each with its own personality, some warmer, some drier, some perfectly still. These layers gently shape the flake as it travels, influencing its form, its speed, and its quiet journey downward. Sometimes, that first flake will melt before reaching the ground. Other times, it will make it all the way, unnoticed, except by those who are watching. But whether or not we see it, the first flake always arrives with quiet purpose, an invisible signal that the snowfall has begun. And with it comes a change in the world's rhythm. The air feels softer, the sounds become hushed, and the sky leans just a little closer to Earth. Tonight, let's linger in that moment. The moment before snow becomes a flurry, before rooftops turn white, before the landscape is transformed. Let's notice the magic of the first flake, because in that tiny crystal, formed high above where no eye can see, lies the entire story of winter's hush, the stillness it brings, the softness it carries, and the quiet promise that more is yet to come. Let's lift gently now, rising through layers of cooler air, up into the cold embrace of the clouds. It is here, within these chilled heights, that snowflakes are born. But their story begins smaller than small, with the invisible. Above us, within thick, towering clouds, countless water molecules drift through the air as vapor. This vapor is weightless, shapeless, unseen. But when it meets something cold enough and stable enough to hold on to, a tiny particle of dust, perhaps, or salt from the sea, it begins to change. The transformation is quiet and profound. The vapor settles onto the particle, and, instead of turning into liquid, it freezes instantly into solid ice. This is the beginning of a snowflake. Not yet the delicate, lacy shape we imagine, but a simple crystal, hexagonal in form. As the crystal remains suspended in the cloud, it gathers more water vapor. Molecule by molecule, it grows. Its 6 arms begin to stretch outward, guided by temperature and humidity. These 2 elements, cold and moisture, are the artists behind every flake's unique pattern. Colder temperatures tend to favor simpler shapes, like flat plates or long needles. Warmer, but still freezing conditions can produce the more complex branching patterns we often associate with snow. Meanwhile, high humidity encourages intricate, feathery designs, while drier conditions keep the crystals smaller and more compact. No 2 flakes are truly alike, not because it's impossible, but because the journey each one takes through the cloud is different. Every layer of air offers new variables. Each moment brings a new balance of moisture, wind, and chill. The path a flake travels shapes its form, its details, and even its density. Some snowflakes grow wide and flat, like tiny stars. Others become slender and column-like, as if built from stacked plates of ice. Some branch out like fern leaves. Others stay as simple prisms. But all of them are governed by the same quiet laws of physics, playing out in the stillness of the cloud. As the flake grows heavier, it begins its descent. Yet, it rarely falls alone. More crystals are forming all around, each dancing downward at its own pace, its own rhythm. Some flakes will brush against one another and join, forming clusters. Others may fragment in turbulence, becoming part of a new flurry. Still others will melt before reaching the earth, becoming raindrops if they pass through warmer layers below. But for those that endure, drifting all the way to the ground, their journey is written in the silence of the sky. Every snowflake is a record of temperature, of time, of atmosphere. Each one a quiet story told in ice. And as they fall, they bring with them not only beauty, but balance. Snow helps regulate our planet's temperature, reflect sunlight, and store precious water. But here, in this gentle chapter of the sky, they are simply wonders. Soft, shimmering shapes. Sculptures made by cold breath and quiet air. Tonight, let's remember how snowflakes are not made in storms, but in softness. Not rushed, but formed slowly and precisely, in the patient chill of the clouds, where vapor becomes crystal, where sky becomes art, and where silence, once again, becomes something you can see. For as long as people have watched snowfall, one idea has danced through imaginations like the flakes themselves, that no 2 snowflakes are alike. It's a lovely thought, isn't it? A whisper of uniqueness in every tiny crystal, that each flake carries its own story, its own signature, and then melts quietly away, never to be repeated. But is it true? Tonight, we drift through the soft world of snowflake science and snowy folklore, a place where myth and meteorology gently meet. The idea that all snowflakes are different comes from both wonder and observation. In the late 1800s, a curious farmer named Wilson Bentley began photographing snowflakes in his small Vermont town. Using a microscope and a bellows camera, he captured thousands of images, each one delicate, detailed, and utterly enchanting. Bentley never found two identical flakes, and from this beautiful truth came the legend, no two are the same. Scientifically speaking, the odds are certainly in favor of uniqueness. Each flake's path through the sky is different, shaped by countless variables: air temperature, humidity, wind, altitude, turbulence. Even subtle changes in these conditions affect how a flake grows, branches, or bends. This means that even if two flakes begin identically, they rarely end that way. But if we look closely, very closely, we begin to see that patterns do repeat. Some flakes grow in classic branching forms. Others resemble columns, plates, or hollow prisms. These general types follow consistent crystalline habits, especially at certain temperatures and humidity levels. So, while the exact details of a snowflake may be unique, its overall form can resemble others, sometimes so closely that differences become nearly impossible to detect without magnification. Researchers have even managed, under tightly controlled laboratory conditions, to create nearly identical snow crystals. In nature, however, such perfect repetition remains incredibly rare. The truth, then, lies somewhere between poetry and physics. Most snowflakes are unique, not because it's impossible for them to repeat, but because nature offers so many possible variations. Tiny differences in the growth environment ripple outward, creating new structures and subtle asymmetries. Like fingerprints, snowflakes belong to broader patterns, but each carries its own texture of time and temperature. And isn't that rather beautiful? That something as small as a snowflake can be shaped by the sky's invisible moods, that it can carry with it a gentle history of the clouds, the cold, the currents. Tonight, as we imagine snow falling softly beyond the window, we don't need to know whether every flake is absolutely unique. We only need to feel the quiet magic in the possibility that, among the millions drifting down, one might be unlike any that came before. Not because it must be, but because nature, in her soft and endless patience, rarely repeats herself the same way twice. Every snowflake you've seen, whether star-like or fern-like, shares a common trait: 6 arms, 6 delicate branches, reaching outward with mesmerizing symmetry. But why 6? Why not 5, or 7, or 10? The answer lies in the quiet world of ice crystals and the invisible order that shapes them. Snowflakes begin, as we've explored, from water vapor in clouds. As that vapor freezes onto a tiny particle, it forms a simple crystal of ice. But ice doesn't form randomly. It follows a precise internal pattern based on how water molecules naturally bond together. Each water molecule is shaped a bit like a tiny V, 2 hydrogen atoms connected to an oxygen atom. When these molecules come together in a frozen state, they arrange themselves in a hexagonal lattice, a repeating 6-sided structure. This hexagon becomes the blueprint for the flake's growth. As more vapor settles onto the flake, it follows the guidance of this crystalline pattern, extending outward in 6 directions, each arm mirroring the others. This is why snowflakes often appear so perfectly symmetrical, even though their environment is far from uniform. Each branch is growing independently, but all are responding to the same molecular rules. They form in harmony, guided by physics, not by chance. The six-sided nature of snowflakes is a beautiful example of crystallography, the study of how atoms and molecules arrange themselves into repeating patterns. And in snow, this pattern is revealed not under microscopes alone, but in every gentle flurry. Yet even within this symmetry, differences bloom. Small changes in temperature or humidity affect how fast each arm grows, or whether branches appear at all. So, while the structure remains hexagonal, the details can vary infinitely. Sometimes a snowflake forms as a flat plate with smooth edges. Other times it becomes a dendrite with intricate fern-like branches. And still other times, the arms are short, thick, or even curled, shaped by warmer pockets of air, gusts of wind, or a flake's own slow tumble through the sky. Despite all these variations, the number 6 remains a quiet constant, a gentle reminder of the molecular harmony beneath the storm. So, the next time you see a snowflake land softly on your glove or window pane, take a moment to admire its design. Within its 6 arms is a story of structure, of science, of softness shaped by symmetry, and above all, of how something so cold can still bring warmth to the heart. Not all snow is the same, and not all flurries feel alike. Some arrive as dry, feathery whispers, light as breath and eager to drift. Others come as heavy, damp clusters that cling to trees and rooftops, turning the world into a quilt of white. Tonight, we'll explore the soft science behind these subtle differences and how the temperature of the air decides the kind of snow we see, hear, and feel. Snow begins in the cold, high places of the troposphere, but the journey it takes to reach the ground passes through layers of air, each with its own temperature and moisture. These invisible paths shape the flake's final form, long before it ever touches your coat or window ledge. At colder temperatures, typically well below freezing, the flakes that form are small, dry, and crisp. These are the snowflakes of powdery slopes and squeaky footsteps. They don't stick together easily, and they often fall in flurries that dance and swirl through the air. If you've ever skied through dry snow or brushed it off your jacket in a puff, you've felt this cold kind. But when the temperature is a bit warmer, just below freezing, the snowflakes begin to carry more moisture. They become heavier, wetter, and stickier. These flakes are larger and more prone to clustering together, creating snow that's perfect for snowballs or sculpting quiet snowmen in the yard. And then there's something in between. Snow that crunches underfoot. Snow that falls in dense, compact grains. Snow that forms small pellets or soft flakes that melt slightly on contact with skin. Each variation is sculpted by air. Air that holds warmth or chill. Air that moves quickly or not at all. Air that has dried out or is saturated with invisible moisture. In this way, snow becomes not just a precipitation, but a reflection of the sky's quiet conversation with the land. A powdery snowfall often means cold, dry conditions, while sticky flakes suggest warmth is nearby. Even a simple flurry can tell a story if we know how to listen. Sometimes snow will start falling lightly, then shift in texture as it continues, changing from dry to damp, or from soft flakes to icy bits. This is the atmosphere speaking through form, telling us that the balance above is shifting. And while it might all look white to the eye, snow's touch, sound, and movement are full of detail. Just as rain has its moods, mist, drizzle, pour, so too does snow. Tonight, let's imagine standing beneath a quiet snowfall. Reaching out your hand, you might feel the soft landing of a dry flake, one that breaks apart like ash. Or you might feel a heavier flake, cool and wet, that lingers before melting slowly into your palm. And as you watch the flurry continue, you'll begin to notice the texture of it all. Not just how it falls, but how it fills the space, how it responds to breath, to light, to silence. The temperature of a flurry is not just a measurement on a scale. It's a sculptor, a shaper of softness, a silent force that turns vapor into poetry. Snowfall has many voices. It can rustle faintly as it collects on tree branches. It can crunch softly under your boots. It can whisper as it drifts against a window pane. But sometimes, snow makes no sound at all. Tonight, let's wander through one of winter's most enchanting phenomena, acoustic snowfall. Oh, moment when the world becomes so quiet. It's as if the snow itself is absorbing every whisper of sound. This hush is not imagined. It's real, measurable, and deeply calming. As snow begins to fall, each flake carries with it a unique structure, full of tiny spaces, delicate branches, and fragile geometry. When fresh snow accumulates on the ground, these spaces trap air, and that trapped air is what gives snow its sound-softening power. In these quiet conditions, snow acts like a blanket laid across the landscape. It muffles echoes, it swallows footsteps, it dims the usual sharpness of sound. Birdsong becomes softer, distant cars seem farther away. Even our own voices feel gentler, as if the world is inviting us to whisper. This effect is most noticeable during the first few hours of a snowstorm, when the snow is still loose and fluffy. Over time, if the snow becomes compacted or begins to melt and refreeze, the softening fades. But in those first fresh moments, the quiet is profound. And it's not just the snow on the ground that contributes to this silence. It's the snow in the air. When flakes fall through still skies, they don't disturb the wind. They don't clash or chatter. They drift, slowly, peacefully. Their descent creates no turbulence, no disruption. This stillness in the atmosphere, combined with the sound-dampening properties of the snow itself, creates what some meteorologists refer to as a quieting layer. It's why snowy evenings often feel like they belong to another world, as if the air itself has pressed pause, as if time is wrapped in cotton, as if the whole landscape is listening to its own breath. Tonight, imagine walking through that quiet, each step softened, each sound distant. You might hear the gentle brushing of flurries against your coat. You might hear nothing at all. And that silence is its own kind of song, a lullaby made not of notes, but of stillness. So, if ever the world feels too loud, or your thoughts too full, remember that snow has a way of softening not just the land, but the spirit. It hushes the world, not by stopping it, but by slowing it, wrapping it in silence, inviting us to listen, to nothing, and in that nothing we find peace. A snowflake seems to weigh nothing at all. It floats, it dances, it drifts, gliding through the sky with no sense of urgency, no sign of effort. It lands without a sound, rests without pressure, disappears without struggle. And yet, even snow has mass. Tonight, let's float into the delicate science of how something that feels so light can quietly add up to so much. A single snowflake, at the moment of its birth, is incredibly small, just a tiny crystal of ice, often no more than 0.1 milligrams in weight. That's 1/10 of a thousandth of a gram, so light that the air itself holds it aloft with ease. But snowflakes don't always fall alone. They often clump together as they descend, gathering into clusters, merging into larger flakes, and growing heavier with each passing moment. Some flakes become big and fluffy, others denser and wetter. A particularly large snowflake, perhaps made of several joined crystals, might weigh as much as 2 or 3 milligrams. Still, that's very little, barely noticeable in the hand. But now, imagine millions of them falling together, over a single neighborhood, a single field, a single city. That's when the magic of accumulation begins. When snow covers the ground, meteorologists often measure it in terms of water equivalent. That is, how much water the snow would contain if it were melted. On average, about 10 inches of fluffy snow equals 1 inch of water. But the ratio can vary, sometimes 5-to-1 for wetter snow, or 20-to-1 for dry, powdery snow. Even light snow can add up quickly. A single inch of snow blanketing an acre of land weighs nearly 5 tons. And in a heavier snowfall, say 10 inches across a whole city, the collective weight becomes almost unimaginable. Roofs carry it, trees bend under it, rivers drink it slowly as it melts and seeps into the earth. And yet, the snowflake itself never feels heavy. It never falls with force. It never arrives with weight that we notice. Instead, snow gathers its mass quietly, softly, without urgency. It is the gentlest kind of accumulation. One flake, then another. No sound, no push, just presence. And that's part of its beauty, because the weight of snow does not come from any single flake. It comes from patience, from persistence, from the slow, consistent layering of the smallest things. There's a quiet metaphor in that too, that even what feels weightless can shape the world. That softness, when steady, holds power. That gentle things, given time, can cover everything. Tonight, as you rest, imagine one snowflake landing, then another, until the ground is no longer bare, until the rooftops are lined in white, until the silence feels full, and the world feels held. Snow arrives in many forms. Sometimes it's just a sprinkle, soft, passing, momentary. Other times, it's something more, a long, steady fall that coats the landscape and lingers for hours, even days. But what makes one a shower and the other a storm? Tonight, let's drift gently into the quiet distinctions between these snowy events. No urgency, no warnings, just soft metrics, peaceful pacing, and the way meteorologists describe the differences in what we see falling from the sky. A snow shower is like a passing thought, brief, scattered, and often light. It may last only a few minutes, or come and go across an afternoon. Snow showers are usually associated with convective clouds, those that bubble up from surface heating or subtle shifts in the atmosphere. These clouds can produce bursts of snow that flutter down, then stop, then begin again. Sometimes you'll see a snow shower in one part of the sky while the sun still shines nearby. These are called snow flurries, gentle, scattered flakes that drift through sunlight like dust in a golden beam. Snow showers usually don't leave much behind, just a dusting, a sparkle, a hint. But a snowstorm is something more structured. It arrives with intention, not loud, not harsh, just widespread and steady. Snowstorms tend to be driven by larger systems, low pressure areas pulling in cold air and moisture over a broad region. The snowfall is continuous, sometimes lasting many hours, or even an entire day. It blankets everything: rooftops, trees, quiet roads, and fields in sleep. Meteorologists define a snowstorm not by panic, but by a few gentle markers. How much snow falls, how long it lasts, how much of the sky it covers, and how visibility is affected. A storm doesn't need to be blinding or loud, it just needs to be sustained. And while snow showers often come and go with minimal accumulation, snowstorms leave behind depth. They settle in, they transform the landscape. Still, both are part of the same soft family, two expressions of winter's breath. One is fleeting, the other embracing, and in both there is peace. Tonight, imagine the beginning of a snow shower, just a few flakes dancing downward. They pass quickly, then fade. Now, imagine a snowstorm, a steady curtain of snow falling from a colourless sky. No hurry, no wind, just hours of snowfall, like time itself is slowing down. Each has its place, each has its rhythm, and each reminds us that snowfall is not a single act, but a language of variation, a vocabulary of softness, measured not just in inches, but in feeling. So whether the snow outside is passing or lasting, light or layering, know that it is speaking in the language of the sky, one flake at a time. High above us, clouds drift across the sky like quiet thoughts. Some are wisps, some are towers, some are broad and grey, stretched across the heavens like brushed silk. But not all clouds can produce snow. Tonight, let's explore the gentle threshold where a cloud becomes more than just vapour, where it quietly crosses into the realm of snowfall. To begin, it helps to know that clouds are made of tiny water droplets or ice crystals, suspended in the atmosphere. Most of them hover without ever letting go. They decorate the sky, painting soft shadows, but never fall. In order for snow to form, certain conditions must align, subtly, patiently, and at just the right height and temperature. One of the most reliable snowmaking clouds is called the nimbostratus. Its name means rain cloud spread out in a layer, but in colder conditions, this same cloud becomes a soft machine for snow. Nimbostratus clouds are thick and low, often blanketing the sky in grey. They don't build upwards like thunderclouds, but stretch out wide, like a heavy quilt laid gently across the sky. When temperatures are below freezing from cloud to ground, they release their moisture not as rain, but as continuous, quiet snowfall. Nimbostratus snow is steady, unhurried. It often creates the kind of snowfall that seems to last all day. Those calm, grey afternoons when the world grows whiter with every passing hour. Another snowmaking cloud is the cumulonimbus, a towering, more dramatic formation, better known for thunderstorms. But in winter, these clouds can also produce snow, especially in bursts. When they do, it's usually during short, intense periods of heavy snow, sometimes with thunder, a rare but real phenomenon known as thundersnow. But let's return to softer skies. Snow also forms in stratocumulus and altostratus clouds, if the temperature and moisture content are just right. These mid-level clouds can gently release flurries, brief dances of frozen air that drift down like whispers and disappear just as quietly. The key, always, is the layering of cold. If the temperature inside and beneath the cloud remains below freezing, the snowflakes can stay intact all the way down. But if the air warms too much, the flakes may melt before reaching the ground, becoming rain or sleet instead. In this way, snow is not just a product of the clouds. It is a collaboration between sky layers, a silent agreement between vapor and chill, a harmony that allows crystals to grow, to gather, and to fall. Tonight, imagine standing under a sky heavy with nimbostratus. You can't see the clouds' tops, only their soft grey base, stretched from horizon to horizon. The snow begins, not in bursts, but in a gentle, continuous fall. No wind, no rush, just a soft surrender from sky to earth. The cloud doesn't roar, it doesn't flash, it simply lets go. And in doing so, it transforms the world below. There are places where winter speaks in a slightly different voice, where snow doesn't follow the same rhythms, where clouds form in unusual shapes and flakes appear suddenly, even when the sky seemed calm just hours before. These are the shorelines of large lakes, and tonight we drift gently into the soft mystery of lake effect snow, a delicate dance between water and sky. It begins with cold air. When a mass of chilly, dry air moves across the surface of a warmer, unfrozen lake, something almost magical occurs. The water, still holding onto autumn's warmth, evaporates into the air above it. This added moisture is then carried upward into the cold air mass, where it cools, condenses, and forms clouds. But these clouds are special. They don't stretch across vast distances like storm systems. Instead, they align into narrow bands, streaks of snowfall that flow downwind from the lake, targeting small areas with surprising intensity. To the meteorologist, this is called fetch, the distance that cold air travels over open water. The longer the fetch, the more moisture is picked up, and the more snowfall can occur. The result? A lake effect snowband. These bands are often long and slender, sometimes only a few miles wide. They can deliver several inches, or even feet, of snow in one town, while a nearby community remains completely untouched. It's a local snowfall, born of specific alignments and subtle conditions. And while the snow may fall heavily within the band, the soundscape is still quiet. There's no thunder, no drama, just a persistent hush as flakes tumble from sky to shore in a rhythmic, watery ballet. The best-known lake effect regions are near the Great Lakes in North America, where cities like Buffalo, Erie, and Syracuse regularly experience these surprise snowfalls. But lake effect snow can occur anywhere cold air moves across warmer water, from small inland lakes to large sea inlets. And though the process is deeply scientific, rooted in thermodynamics, convection, and wind direction, it feels like poetry. Water rising, air cooling, snow descending, a cycle that begins in warmth and ends in stillness. Tonight, picture this, a solitary lighthouse at the edge of a lake, cold air sweeping in from the north, a sky that seems to form clouds right before your eyes, and then snow. Not from a storm system, not from distant clouds, but from the water itself, gently becoming sky, and then becoming snow, falling like breath, settling like sleep. Lake effect snow is winter's quiet improvisation, a soft surprise, a reminder that snow, like dreams, can come from unexpected places. Have you ever stepped outside during a snowfall and noticed the silence? Not just a lack of noise, but a presence of quiet. A stillness so deep, it feels like the world has been gently muted. The crunch of your own footsteps becomes the loudest sound around, and even that feels softened, absorbed. Tonight, let's rest in that hush and explore the gentle science behind one of winter's most calming mysteries, the quiet blanket effect. When snow covers the ground, it doesn't just decorate the landscape, it transforms the way sound moves through the air. Freshly fallen snow is made up of countless delicate crystals, each with intricate shapes and airy spaces between them. This fluffy structure creates a surface that is incredibly effective at absorbing sound waves. Instead of bouncing off the ground and echoing outward, sound becomes trapped in the snow's tiny voids and passages. In effect, the snow swallows noise. It dims the sharpness of footsteps, the hum of distant cars, the chatter of wind through trees. This muffling is strongest right after a snowfall, when the snow is light, dry, and loosely packed. As it settles, compacts, or melts and refreezes, it loses some of that quieting quality. But in those first fresh hours, the effect is unmistakable. Meteorologists and acousticians alike have studied this phenomenon. And while snow's sound-absorbing properties can be measured, its emotional effect is something more subtle. It brings not just silence, but serenity, a feeling that the world has slowed down, that time itself is treading softly. The quiet isn't empty, it's full of stillness, of space, of peace. Even the way we speak changes in snowy environments. Voices tend to lower. Conversations become whispers. The atmosphere invites a kind of reverence, a natural hush that soothes the nervous system. Animals respond too. Birds hunker down, their calls less frequent. Even the usual rustle of leaves or grass is absent, tucked beneath a layer of white. The result is a soundscape unlike any other season. Calm, gentle, dreamlike. And there's more. Snow doesn't only absorb sound from the ground up, it also affects the acoustics of the entire landscape. Forests blanketed in snow reflect less sound. Urban streets grow quieter, even under busy skies. The cold, dense air near the surface slows sound waves down, stretching them, making the world feel even more subdued. So, when it snows, we don't just see a different world, we hear one. Or rather, we hear less of it. And in that soft reduction, our senses find space to breathe. Tonight, as you listen to the imagined hush of snowfall, let it settle into your thoughts like snow upon a field. Let the noise fall away. Let the softness remain. And know that the quiet blanket is not just over the land, but around you too. There's something magical about snow at night. Even under a cloudy sky or a new moon, when darkness should rule the world, snow has a way of glowing. It's not a glow like fire or electricity. It's softer, dimmer, like the memory of light lingering in the air. Tonight, we'll drift into the science and softness behind this snowy shimmer, how snow, even in silence, catches light and scatters it into dream. The secret lies in snow's structure. A single snowflake is a crystal, a delicate lattice of frozen water, full of angles, edges, and tiny mirrored surfaces. When millions of these crystals collect on the ground, they create a layered surface unlike any other. Not flat, not smooth, but full of miniature prisms. These surfaces interact with light in a special way. When a light source, like a street lamp, a porch bulb, or even starlight, touches the snow, it doesn't just bounce in one direction, it scatters. That scattering is called diffuse reflection. Instead of a single beam bouncing back, the light is broken into countless rays, each gently redirected. Some go upward, some sideways. Some sink into the snow, bouncing between crystals before emerging in a softened glow. This is why snow-covered ground often looks brighter than bare earth at night. Even the faintest illumination becomes multiplied, spread across the surface like a thin film of starlight. Clouds, too, play a role. On overcast nights, low clouds catch city light and reflect it back downward. Snow then reflects that light again, creating an ambient brightness, one that feels almost ethereal. A snowy field on such a night can appear silver, almost blue. A backyard becomes a quiet stage of luminescence. Shadows soften, edges blur, and in the deepest woods or quietest hills, even moonlight is enough. Snow amplifies its glow, painting the world in quiet grayscale. Paths become visible, trees shimmer faintly. The world doesn't disappear into black, it becomes a quiet theatre of gentle light. This glow isn't just physical, it's emotional. It makes us feel safe, or nostalgic, or curious. It draws us into the night instead of keeping us away. It's why winter walks after dark feel calmer, less intimidating. Snow changes the very texture of nighttime, and the glow changes with the type of snow. Fresh powder scatters light more evenly, creating a soft, velvety sheen. Icy snow crusts can reflect light sharply, sparkling in brief flashes. Wet snow reflects more directly, often glowing under nearby lamps like polished marble. But always, there is softness, a kind of borrowed light, quiet, dim, enough to see by, but not enough to wake the world. Tonight, close your eyes and imagine standing beneath a dark sky surrounded by snow. No moon, no stars, just the faint glow of the world beneath your feet, whispering that even in the dark, light can find its way. Even in stillness, snow can shine. Even in silence, snow remembers the sun. Snow may seem simple, white, falling, quiet, but in the world of weather, snow has many names, and each carries its own gentle distinction, its own mood, texture, and rhythm. Tonight, let's sift through the soft vocabulary of frozen precipitation, not as a lesson, but as a dream, drifting slowly through the different forms that snow can take, and the beautiful words we use to describe them. We begin with the most familiar, snowflakes. These are the delicate crystals we imagine when we think of snowfall, symmetrical, six-sided, and floating gently through the air. Snowflakes form when water vapor freezes directly into ice, creating intricate shapes that grow as they drift through cold, moist layers of the atmosphere. When snowflakes fall lightly and sporadically, we call it a flurry. Flurries are gentle bursts of snow, brief, scattered, and soft. They rarely lead to accumulation, but they bring beauty in passing. Like thoughts drifting through a sleepy mind, flurries come and go with little need for attention. Next, there is sleet. Sleet begins as snow high in the clouds, but encounters a thin layer of warmer air as it falls. This causes the flakes to partially melt. Then, if the air near the ground is cold again, the droplets refreeze into small, round ice pellets before reaching the surface. Sleet is often mistaken for snow, but it has a firmer touch, a soft rattle instead of a whisper. Then comes graupel, a word as gentle on the ear as the form it names. Graupel occurs when a snowflake passes through supercooled water droplets, tiny drops that remain liquid even below freezing. These droplets cling to the flake and freeze, forming a soft, opaque coating around the crystal. The result is a snow pellet, rounded and fluffy, like a snowflake dressed in a winter coat. Graupel feels light to the touch, crumbles easily, and falls with a hush. It's softer than sleet, less defined than hail, and uniquely quiet in its descent. There's also snow grains, which are tiny, flat ice particles that fall slowly and often go unnoticed. They don't bounce, they don't sparkle, they simply settle, like powder sifted through a fine screen. Each of these terms, flurry, sleet, graupel, snow, grain, is part of the language meteorologists use to describe the frozen stories unfolding in the air, not as warnings, not as alarms, but as careful observations of nature's poetry. Tonight, as you rest, you might imagine these forms not as categories, but as characters, each with their own personality. The flurry, light and quick, a momentary dancer. The sleet, firm and precise, a gentle percussionist. The grauple, soft and rounded, a winter storyteller. The snow grain, quiet and constant, like breath. And through them all, the sky writes its message in frozen syllables. A snowfall is not just one thing, it's many, many textures, many sounds, many names. And in knowing them, we learn to listen more closely to the air, to the quiet, to the language of the sky. Predicting snowfall is both a science and an art. It may seem like a straightforward question. Will it snow? How much? When? But in truth, snowfall is shaped by so many quiet variables that forecasting it becomes a practice in softness and patience. Tonight, let's drift gently behind the scenes and see how meteorologists try to read the sky's future, using models, maps, and delicate probability, not with certainty, but with care. To forecast snow, we begin with weather models, mathematical simulations of the atmosphere. These models use current observations, temperature, pressure, humidity, wind speed, and project how those conditions might evolve over time. There isn't just one model, but many. Some are global, looking far and wide across oceans and continents. Others are regional, focused closely on the patterns of a single coastline or mountain range. Each model produces data, lines, shapes, colors, and numbers. But interpreting that data requires human touch. Meteorologists don't just rely on what the models say. They compare them, blend them, consider past trends, local geography, and intuition built over seasons of study. Snowfall is especially tricky to predict because it depends not just on whether precipitation will fall, but on whether the air is cold enough, all the way from the clouds to the ground, for that precipitation to remain frozen. A thin layer of warmth between two cold layers can melt a flake and refreeze it, or melt it just enough to turn it into freezing rain, or let it fall as sleet. Each change is small, just a degree or two, but it can reshape the entire forecast. Then there's the moisture question. Will the air hold enough water vapor to support sustained snowfall? Dry air can evaporate flakes before they reach the ground. Wind patterns can shift bands of snow just miles away from where they were expected. A snowstorm that was predicted to bring 6 inches may deliver 2 or 12. This doesn't mean forecasts are flawed. It means the atmosphere is subtle, and forecasters must match that subtlety with calm understanding. That's why you often hear snow predictions framed in ranges, 1 to 3 inches, or light accumulations possible. These aren't guesses. They're reflections of uncertainty handled gently. They're invitations to be aware, not afraid. And when forecasts shift, when snow arrives earlier or falls longer than expected, it's not a failure. It's a reminder that the sky is alive. And prediction is not prophecy. It's preparation. Tonight, imagine a meteorologist at their desk, studying soft waves of color on a glowing screen, watching models update, listening to radar pulses, comparing patterns, looking not for drama, but for harmony, searching for clues in the quiet math of air. And when they say, a chance of snow, know that what they're really saying is, we've listened, we've watched, we've traced the sky, and we think winter may whisper through your window soon, perhaps lightly, perhaps long, but always with beauty, always with care, before snow reaches the valleys, before it blankets towns and fields. It often begins higher up, along the shoulders of mountains. Tonight, we'll climb slowly, softly, following snow to the heights where it often first appears. We'll explore the quiet reasons why snowfall begins with elevation and how mountains hold a special relationship with the sky's frozen gifts. The first key to snowfall at altitude is temperature. As we rise upward through the atmosphere, the air grows colder. This cooling follows a gentle pattern known as the environmental lapse rate, a slow decrease of temperature, usually about 6.5 degrees Celsius for every kilometre gained in height, or around 3.5 degrees Fahrenheit for every 1,000 feet. This means that while it may be raining in the valley, it can be snowing high above, where the air has cooled just enough for water vapour to freeze. Mountain peaks often sit nestled within that colder part of the troposphere, the perfect zone for snow to form and fall. But altitude isn't just about being high. It's about what air does when it reaches those heights. Enter orographic lift, a gentle upward motion in the atmosphere, caused by terrain. When moist air encounters a mountain, it's forced to rise. As it climbs, it cools. As it cools, the moisture within it condenses, and, if the conditions are cold enough, freezes. This process creates clouds along mountain slopes and often leads to precipitation, snow when the air is below freezing. It's a silent exchange between landscape and sky, the mountain lifting the air returning snow. Some of the snowiest places on Earth aren't in the far north, but on windward mountain slopes, where orographic lift quietly delivers steady snowfall day after day. And while we often imagine mountain snow as harsh or wild, there is deep stillness at altitude. High above, where the world grows quiet and the trees begin to thin, snow can fall in complete silence. No cars, no chatter, just wind through pine needles and the hush of flakes brushing alpine stone. In these elevations, snow lingers longer too. Temperatures stay colder. Sunlight takes longer to melt it away. Entire snowpacks build slowly over weeks, storing water that will one day feed rivers, lakes, and streams far below. Tonight, imagine yourself gently ascending along a trail dusted with snow, past bare branches and frost-laced rocks. As you rise, the air becomes thinner, quieter. A few flakes begin to fall, then more, until the entire path is wrapped in white. You pause, looking back toward the valley, still green and dry, and ahead, the mountain whispers winter. Up here, snow doesn't just fall, it belongs. Snow rarely stays exactly where it lands. Even when the sky has gone still and the last flake has fallen, the story of snowfall continues, carried gently by the wind. Tonight, we'll wander through the quiet movement of drifting snow and the beautiful shapes it leaves behind. Picture a snowy field, open, undisturbed. At first, it's evenly coated, each flake settling calmly atop the next. But when wind begins to stir, something quiet and magical begins. Snow, especially dry and powdery snow, is light enough to be lifted and carried again. A breeze moves across the surface, picking up tiny crystals and setting them adrift. They don't blow in a chaotic gust. They tumble, bounce, and roll, a process called saltation, a slow-motion dance across the landscape. Over time, these gentle movements begin to sculpt the snow into new forms. Snowdrifts. They curl and lean like waves frozen in motion, against fences, along tree trunks, in the corners of rooftops and barns. Drifts gather where the wind pauses or swirls, accumulating not randomly, but rhythmically. In wide open places, drifts can grow tall, soft ridges shaped like dunes in a winter desert. On rooftops, they pile unevenly, creating rounded forms like spilled cream. And on roads and walkways, they sometimes spill across with feathered edges, tracing the memory of the breeze that carried them. There is artistry in this. Wind becomes a sculptor. Snow becomes the medium. No two drifts are alike. Some are shallow and long, barely rising above the ground. Others are steep and curled, their surfaces carved by hours of slow shifting. Even a single gust can change their shape, flattening one edge, lifting another. And always there is movement, even if it's almost imperceptible. On colder nights, when the air is still but not frozen solid, the top layer of snow may begin to sublimate, evaporating directly into vapor, reshaping the drift once again. Drifting snow also plays a role in ecology. It creates shelter for small animals, forming natural insulation against the wind. Beneath a drift, the air is warmer than above it. Some creatures sleep there, others burrow. Life, hidden in sculpted silence. And when the sun rises, its light adds another layer of artistry. Shadows stretch across the curves. Highlights shimmer along the edges. The drift becomes a painting of pale blue and soft white. Tonight, picture yourself standing near a fence in an open field. The wind has settled. The stars are out. Around you, snowdrifts curve like frozen ocean swells, each one shaped by wind's invisible hand. There is no noise, only form, no rush, only rest. Snow may fall, then move again, but it never hurries. It glides, it gathers, it drifts, and in doing so, it shows us that stillness can also come from motion. That softness is not always still, but always gentle, and that the quiet shapes around us are often drawn by things we cannot see, but can feel. Snow changes more than the landscape. It also changes how we hear the world. Tonight, let's rest within that subtle transformation. The way falling snow reshapes the pathways of sound, creating a soft, distant hush that feels like the earth itself is whispering. When snow begins to fall, the very first thing we often notice isn't visual, it's audible, or rather, inaudible. Suddenly, the world becomes quieter. Footsteps no longer echo. Distant noises fade into stillness. Even our own voice feels gentler, like we're speaking into a pillow of air. This isn't just a feeling, it's physics. Fresh snow is made up of millions of tiny crystals, each with intricate shapes and spaces between them. When snow covers the ground, it acts like a thick, porous blanket, absorbing sound waves instead of bouncing them back. High-frequency sounds, like voices or the crunch of leaves, are especially softened. Instead of carrying outward, they get trapped in the fluffy surface, caught in the microscopic air pockets between flakes. It's as if the snow is listening and holding the sound close. At the same time, the air during snowfall also contributes to this hush. Snow usually falls on calm days when wind is minimal and temperatures are low. Cold air is denser and tends to slow the movement of sound waves, making everything feel more distant. As snowflakes drift downward, they create a sound barrier, tiny ice crystals absorbing, bending, and scattering vibrations. If you've ever walked through a snowfall at night, you may have noticed how surreal it feels. You can hear your own breath. You can hear the gentle brushing of your coat, but sounds beyond a few steps away begin to disappear. Snow alters the shape of sound, not just its volume, but how far it travels and how clearly it returns. In open fields or wooded paths, the effect is even more pronounced. A car in the distance becomes a faint hum. A nearby bird call turns into a whisper of itself. It's as if the snow has pressed a gentle finger to the world's lips and asked for quiet. Even after the snow has stopped falling, the softness continues, especially when the snow remains fresh and uncompacted. As time passes, wind, melting, and refreezing begin to change the structure of the snow, reducing its sound-absorbing quality. But for a while, the world stays hushed. Some say it feels like being wrapped in cotton. Others call it dreamlike. Whatever the name, the sensation is deeply calming. And so tonight, imagine yourself standing in a snowfall, flakes drifting all around, landing softly on your coat and shoulders. The sky is quiet, the land is quiet, and your thoughts begin to soften too. The snow isn't just falling, it's shaping silence. And in that silence, there is peace. Not all snow feels the same beneath our feet. Some snow is light and dry, puffing away as you step. Some is sticky and wet, clinging to boots and gathering in clumps. Others crunch crisply or squeak underfoot, leaving a satisfying trail of sound as you move. Tonight, let's step softly through the different textures of snow and how they form, feel, and flow through the winter world. The type of snow that falls depends on a delicate balance of temperature and moisture, not just in the sky, but also on the ground. And those differences give rise to some beautifully descriptive names. The first, and perhaps most beloved, is powder snow. Powder is the softest, driest form of snowfall. It forms when the air is very cold, well below freezing, and contains just the right amount of moisture to build light, feathery crystals. These flakes fall gently and don't stick together, creating a snowpack that's airy and loose. When you walk through powder, it swirls around your boots like smoke. When you fall into it, it cushions you without clumping. Skiers treasure powder for its silky glide. And for walkers, it feels like stepping through clouds. Next, there is slush. Slush forms when snow begins to melt, either because it fell when temperatures were near freezing, or because the ground below was warm. Slushy snow is wetter, heavier, and more pliable. It has a distinct texture, part snow, part water, part soft ice. Your boots may sink with a squelch, and it tends to gather in puddles that shimmer under streetlights. Though less romantic, slush is part of snow's life cycle, a sign that warmth is nearby and the seasons are whispering back and forth. Then there's a special kind of snow called sugar snow. This form appears when melted snow refreezes into coarse grains, especially during cycles of thawing in the day and freezing at night. Sugar snow isn't fluffy like powder or wet like slush. It's grainy like sand, and it often squeaks underfoot in the cold morning hours. It's beautiful to the touch, tiny, glimmering crystals that shimmer in sunlight or starlight. There are others too. Crust snow forms when a layer of ice hardens on top of softer snow. It crackles as you step through. Corn snow, found in springtime, has a granular texture that forms as snow melts slowly during warm days and refreezes each night. Each type of snow tells a quiet story about the temperature, the moisture in the air, the time of day, and even the slope of the land. You can learn to read these textures not with science alone, but with your senses. Listen to the crunch. Feel the give. Beneath your feet, watch how the snow holds shape or doesn't. Tonight, imagine walking slowly through different snowy paths. First through powder, soft, dry, silent. Then through slush, cool, heavy, and wet. Then across a patch of sugar snow, fine and grainy like soft crystal underfoot. Each step has a voice. Each texture has a personality. And each reminds us that snow isn't a single thing. It's a spectrum of softness, a landscape of feeling, a winter made not just of white, but of touch. Snow doesn't just fall, it shines. Even long after it touches the ground, snow continues to interact with the sky through a soft and silent power called albedo. Tonight, we'll drift into this gentle concept where light and surface meet, and snow becomes more than just a blanket. It becomes a mirror. Albedo is a term used in meteorology and climate science to describe how much sunlight a surface reflects. Different surfaces reflect different amounts. Dark pavement, for example, absorbs most of the light that hits it, warming quickly. Grass reflects more, and white sand even more than that. But snow, especially fresh, untouched snow, has one of the highest albedo values of all. It reflects up to 80 to 90% of the sunlight it receives. This means that when sunlight falls on snow, most of it is sent gently back into the sky, rather than being absorbed into the earth. The result is not just a visual brightness, but a real impact on temperature and climate. During the day, snow-covered landscapes tend to stay cooler than snow-free ones. The reflected light keeps surface temperatures lower, helping to preserve the snowpack and slow melting. On a broader scale, this cooling effect contributes to balancing our planet's energy, especially in the polar regions, where snow and ice reflect vast amounts of solar radiation. The more snow there is, the more light is reflected, and the cooler the surface remains. This delicate feedback loop is part of what helps stabilize seasonal temperatures. But albedo is also deeply poetic. It explains why winter feels brighter, even when the sun hangs low, why a snow-covered field seems to glow from within, why, even on overcast days, the world can feel softly lit. At night, albedo takes on a different kind of beauty. Streetlights, moonlight, even faint starlight find their way down to the snow's surface and bounce back upward in a subtle, silvery glow. The snow doesn't just reflect, it diffuses, spreading light gently in every direction. This is why snowy nights often feel less dark. The ground itself lends its light to the sky, and just as snow reflects light, it reflects stillness too. It quiets the landscape, it softens motion, and in reflecting light, it invites us to notice how even something cold can feel warm when it shines. Tonight, imagine lying in a snowy field beneath a pale moon. The light is soft, the world is still, and all around you, the snow is glowing, not because it makes its own light, but because it quietly reflects what is offered. Albedo is the science of reflection, but in snow, it becomes an art. It seems like a contradiction. Snow is cold, it chills your fingers, it melts on your skin, it falls from icy skies, and yet, snow is also a blanket, a quiet, natural insulator that keeps warmth tucked beneath the surface. Tonight, let's settle into this gentle paradox and explore how snow protects the earth, not just by covering it, but by preserving the heat that lies below. Snow is made of ice crystals, fragile, airy structures with space between them. When snow accumulates on the ground, it traps air in these spaces, creating a layer that resists the flow of heat. This layer acts much like the insulation in your home, slowing the transfer of warmth from one side to the other. Beneath a layer of snow, the soil doesn't freeze as quickly. Temperatures below the snowpack remain relatively stable, even when the air above grows bitterly cold. In fact, just a few inches of snow can keep the ground beneath several degrees warmer than the surrounding atmosphere. This effect is especially important in nature. Under snow, seeds rest quietly, protected from harsh freezes. They wait for spring, sheltered by the very snowfall that seems, at first glance, so severe. Small animals, too, benefit from this quiet cover. Mice, voles, and other creatures create tunnels beneath the snow, where the air is calm and the temperature is bearable. It becomes a subnivean world, a hidden winter habitat beneath the white. Footsteps above go unnoticed. Predators pass by, and within the snow's silence, life goes on. Even plants benefit. Snow covers low shrubs, insulating branches and buds from freezing winds. Trees collect snow on their limbs, and though the weight may bend them, the snow also shields their bark from direct exposure to extreme cold. In places where snow cover is consistent through the winter, the earth rests more easily. It breathes through the frost. It sleeps, but not in discomfort. And when spring finally arrives, the snow doesn't vanish. It melts slowly, gently feeding the soil below. The same snow that insulated now nourishes. There's a peaceful lesson in that even what seems cold can offer warmth, that even what falls can also protect. That softness, when layered, can shield what matters most. Tonight, picture the snow not just as scenery, but as shelter, a blanket draped across fields, a gentle roof over burrows, a quiet quilt for the earth. It does not rush, it does not shout, it simply covers, and in covering, it comforts. Snow is not just a visitor of winter, it is part of how winter sustains the world, one soft layer at a time. Snow has a way of softening everything it touches, even the city. Beneath glowing towers and winding streets, where sound is usually constant and motion never truly stops, a gentle snowfall brings a different rhythm, one that hushes, one that settles, one that reminds us that even in the most built-up places, winter has its own quiet magic. Tonight, we'll glide into this urban snowfall, where streetlights glow through drifting flakes, where alleys grow quiet, and where the city seems to take a breath. As snow begins to fall in a city, it interacts with more than just rooftops and sidewalks. It finds its way around buildings, over bridges, down fire escapes, and through the intricate maze of urban structures. Skyscrapers create wind tunnels, alleyways funnel the breeze, tall walls cast shadows that change the rate of accumulation. In open parks or broad avenues, snow might settle evenly, blanketing everything in a clean white cover. But on narrow streets and busy intersections, it clings in corners, curls in drifts, or melts as it hits warm surfaces. It becomes a city artist, sketching quiet patterns into the built world. And then there is the light. Snow reflects the glow of traffic lamps, neon signs, and apartment windows, scattering them into soft halos. The air itself takes on a subtle shine. Under snow, a yellow streetlight can feel golden. A red taillight can stretch across the pavement like watercolor. Even a flickering cafe bulb seems to shimmer through the snowy hush. This reflection is especially visible at night, when albedo turns the snow into a mirror for the city's quiet glow. And the result? A kind of urban lullaby. Not loud, not bright, but softly glowing, layered with warmth and distance. Sound, too, is transformed. City noise doesn't vanish under snow, but it bends, it dims, it recedes. Tires make a softer sound against the road. Sirens seem to stretch out rather than pierce. Voices echo more gently across snowy courtyards. It's not just quieter, it feels further away, and that distance can feel restful. Even inside an apartment, behind windows and walls, you can sense when it's snowing. The world moves more slowly, fewer footsteps, fewer car horns. The usual rhythm softens. People pause. They walk slower. They look up more. Snow doesn't just arrive in the city. It changes the city. It turns the bustling into the peaceful. It turns the crowded into the calm. It takes what is hard, glass, concrete, steel, and gives it a layer of softness. Tonight, imagine standing on a quiet urban street. Snow drifts beneath a glowing lamppost. Rooftops are traced in white. Footprints vanish behind you as the flakes fall faster. You're not far from home, but you feel far from everything. The city is still here, but it's dreaming, and so are you. Snow doesn't just fall and vanish. Layer by layer, it builds. And when it stays, when the flakes continue to arrive, day after day, gently covering what came before, it becomes something new, a quiet structure beneath our feet. A soft, hidden world that holds the memory of many snowfalls. Tonight, let's rest inside the stillness of snowpack, a slow formation shaped by time, temperature, and silence. Snowpack begins when multiple layers of snow accumulate over days or weeks. Each new layer rests atop the last, like pages of a winter story. Some fall during gentle flurries, others arrive after heavier snowfalls. Some layers are dry and airy, others wet and heavy. Each one is different. At first, the layers remain loose. You can walk through them easily. The snow shifts and fluffs beneath your steps. But slowly, quietly, the snow begins to settle. Gravity presses down. The air between the flakes escapes. The crystals begin to change shape, bonding more tightly. This process is called metamorphism, and it transforms soft flakes into denser grains over time. There are two main kinds of metamorphism at work here. Destructive metamorphism occurs when freshly fallen snow settles. The sharp arms of the flakes break down, becoming rounded. The structure loses fluff, gaining strength. Constructive metamorphism happens when temperature gradients within the snowpack cause moisture to move from warmer to cooler areas. Crystals grow in new patterns, sometimes forming delicate chains or even ice. Lenses, small, clear layers within the snow. These subtle shifts create a stratified snowpack, one made of distinct layers, each with its own texture, density, and temperature. Scientists often study these layers by digging snow pits and analyzing the structure. But for most of us, the snowpack is simply what we feel beneath our boots. Sometimes soft, sometimes firm, sometimes both. Snowpack also serves many gentle purposes. It stores fresh water, slowly releasing it as it melts in spring. It protects the soil and seeds below, acting as insulation against harsh cold. It provides habitat for winter creatures who live in the air gaps between layers. And it even acts as a quiet archive, preserving atmospheric particles, pollen, and memories of past storms for those who know how to read it. The snowpack is not just snow, it's a record, a blanket, a breath, and while it may seem motionless, it's always changing, settling, shifting, compressing, warming. Tonight, imagine walking across a snow-covered field. The top layer crunches softly. Beneath that lies another, softer, older, perhaps from a week ago. Beneath that, another still. A buried landscape of gentle layers, resting beneath your every step. It holds weight, but not pressure. It carries time, but not urgency. It supports you, but asks for nothing in return. Snowpack is winter's foundation, and like all soft foundations, it holds everything quietly. Sometimes, a snowfall doesn't begin with flakes. It begins with raindrops. And in that quiet transition, from liquid to crystal, from fall to float, there is something delicate, something magical. Tonight, we'll trace the soft threshold where rain becomes snow, following the journey of each drop as it crosses that gentle divide in the sky. When precipitation forms in clouds, It often begins as ice crystals, even in warmer seasons. High in the atmosphere, where temperatures are almost always below freezing, water vapor condenses and freezes onto tiny particles, dust, salt, or other microscopic seeds. But whether those crystals remain snow or melt into rain depends entirely on the temperature layers they pass through as they fall. If the air beneath the cloud is warm enough, the flakes begin to melt. The snow becomes droplets, falling faster, heavier, striking rooftops and windows as rain. But when a cold front approaches, or the surface temperature quietly dips below zero, something beautiful happens. The rain begins to slow, the drops become cooler, then they begin to refreeze. If the cold layer is deep enough, the liquid transforms back into solid, turning into snowflakes once more before they reach the ground. This transition is not abrupt. It happens in gentle gradients. You might step outside and feel cold rain, only to notice that some of the drops are starting to sting less, falling softer, slower. Then, among the rain, you see a few mixed flakes, hesitant but real, a signal that the atmosphere is changing. This mixture is often referred to as rain-snow mix, a liminal weather state, a moment between identities. Sometimes the rain passes through a shallow layer of cold air, not enough to become snow, but enough to create sleet, tiny ice pellets that rattle gently as they land. Other times, the raindrops freeze on contact with cold surfaces, forming a glaze known as freezing rain. But if the cold is deep, wide and quiet, then true snow begins. And when it does, there's a shift in feeling. The sounds grow softer, the pace of the storm slows. Rain might rush, but snow never does. It drifts. Tonight, imagine standing beneath a grey sky. You feel the cold drops at first, small, steady, tapping against your coat. Then, slowly, the sound begins to fade. You see a flake, then another. Soon, the raindrops vanish completely, replaced by a silent ballet of crystals descending. It's not a storm, it's a change, a gentle turning of the page in the sky. And just like that, rain becomes snow, not with a roar, but with a whisper. Snow forms at many temperatures, but the coldest kinds arrive in the quietest moments, under the calmest skies, when the air is so dry and frozen that even sound seems suspended. Tonight, let's drift into that deep chill and explore the rare, crystalline snows born in the most frigid corners of the atmosphere. When the temperature drops far below freezing, sometimes well below 15 or 20 degrees Celsius, the nature of snow changes. The air contains less moisture, the clouds become thinner, and the snowflakes that form are smaller, more fragile, and more intricate than their warmer counterparts. These are known as diamond dust, Arctic crystals, or simply cold snow. Instead of large, branching flakes, the crystals tend to be tiny and feather-light. So light, in fact, that they almost float in place. They sparkle in sunlight or moonlight like powdered glass, barely visible until they catch the light just right. Sometimes, these crystals don't even fall from clouds. They form near the ground, when moist air meets extremely cold surfaces. The vapor condenses directly into ice, creating a shimmering, drifting veil that seems to hover in midair. This phenomenon is most common in polar regions or high mountain valleys during periods of calm, clear, cold weather. But it can happen anywhere when conditions are just right. Cold enough, still enough, and quietly balanced. The snow that forms in these deep freezes is often described as squeaky underfoot. You may have felt it before, walking through snow that chirps or squeals faintly with each step. This happens because the cold, dry crystals resist compression, creating friction as you move across them. The air itself in these conditions is remarkable. So clear, so still, so dry. Sounds carry farther, yet feel muted. Everything seems suspended in time. Even your breath curls slowly in front of you, hanging longer than usual before fading. And when you look upward, the sky seems sharper. The stars feel closer, and falling snow looks more like drifting glitter than flakes. This kind of snow rarely accumulates deeply. It arrives gently, rests lightly, and sometimes vanishes with the morning sun. But its presence lingers. There's something unforgettable about the coldest snow, its delicacy, its sparkle, its silence. It doesn't cling, it doesn't pack, it doesn't weigh anything down. It just exists, pure, effortless, and momentary. Tonight, picture yourself in that still place, the landscape wide and open, the trees silent, the sky dim and violet blue, and all around you, glittering crystals drifting downward like wishes, too delicate to catch, too beautiful to hold, and yet enough to fill the world with wonder. Must travel a winding path through invisible layers of air that shape its form, slow its descent, and carry it gently to earth. Tonight, we'll float with the snow as it falls, layer by layer, through the troposphere, the lowest level of our atmosphere, and the only one where weather like snow can exist. The troposphere stretches from the surface of the Earth to about 8 to 15 kilometers high, depending on your location. It's deepest near the equator and shallower near the poles. This is where clouds form, winds blow, and temperature begins to fall with altitude. At the very top of this layer, in the coldest reaches, snowflakes are born. Up here, water vapor turns to ice, not through melting or condensing, but by deposition, a quiet transformation where vapor becomes solid, forming the first small crystal around a microscopic nucleus. It may be a speck of dust, a grain of salt, or a tiny bit of pollen. That one particle begins the whole journey. As the flake begins to fall, it encounters its first air layer, a region cold enough to help it grow. With every passing second, the snowflake gathers more vapor, building its shape. Arms branch outward. Symmetry forms. This is where the flake becomes what it is: unique, crystalline, delicate. Below that, it enters a slightly warmer layer. Here, the snowflake may begin to change. The edges may soften. The branches may grow more feathery or slightly rounded. If the temperature here is still below freezing, the snowflake remains intact, but its journey is subtly shaped by the temperature and moisture in this band of air. Next comes a drier layer, where some snowflakes may even begin to shrink, slowly sublimating into vapor again. Others continue on, smaller but whole. Then, perhaps a layer of turbulence, where wind moves differently at each height. Snowflakes begin to drift sideways. They may collide with others, combining to form larger flakes. Or they may fragment, breaking into soft flurries. Lower still, the air thickens. Gravity pulls more firmly. The snowflake's descent begins to straighten, its path steadier. It is no longer just falling, it is approaching. The lowest layer near the surface can determine everything. If this air is cold, the snowflake will survive intact, landing on rooftops, treetops, and windowsills as a perfect ice crystal. But if this layer is too warm, even just slightly, the flake may melt, becoming sleet, rain, or a droplet of water on your glove. Every layer matters. Each acts as a silent editor, shaping the flakes' journey. And yet, through it all, snow continues to fall, softly, patiently, silently. Tonight, picture yourself floating downward, like a snowflake, through these invisible layers of air. High above, where it all begins, quiet, cold, and still. Down through the sculpting temperatures and guiding breezes, through turbulence and calm, until at last you drift down to earth, lightly, without sound. Part of a snowfall the world below has been waiting for. Have you ever stepped outside before a snowfall and felt it in the air before a single flake appears? Some say they can smell snow coming, not like a scent exactly, but something subtler, a crispness, a clearness, a hush in the atmosphere that carries more than just temperature. Tonight, we'll wander into that mystery, gently exploring the quiet meteorology behind why, sometimes, you really can sense that snow is on the way. While snow itself has no strong odour, the conditions that precede snowfall can create a distinct feeling in the air, what some describe as the smell of snow. One part of this sensation is tied to humidity. Before snow begins, the atmosphere often grows slightly more humid at low levels, even if the air still feels dry. This moisture carries with it a faint freshness, a cool, clean quality that feels different from rain. The air feels open, like it's waiting. Then there's temperature. As the air cools rapidly ahead of a snow event, chemical reactions on surfaces slow down. Volatile organic compounds, those invisible particles that give rise to smells from soil, trees, or pavement, are released less actively. This means the air loses some of its usual earthy or leafy background scents. The result? A kind of olfactory quiet, a blankness that feels fresh. Barometric pressure also plays a role. As a snowstorm approaches, the pressure often drops slowly. This subtle change alters how air moves and how scents are carried. With snowstorms, the movement tends to be gentle, a soft draw rather than a sharp gust. The stillness helps preserve whatever trace particles are already in the air. Then there's ozone. Sometimes, during winter weather patterns, especially those involving high-altitude disturbances, small amounts of ozone are drawn downward. Ozone has a faint, slightly metallic scent that can be detected even in low concentrations, and for some, it's a signal that snow is coming. And finally, there's memory. Your senses remember the conditions that surrounded past snowfalls, the way the sky looked, the feeling on your skin, the quiet just before the flakes began. When similar conditions return, your brain recalls those sensations and associates them with snow. So while smelling snow may not be about detecting frozen water directly, it is real. It's a symphony of atmospheric cues, humidity, cold, stillness, pressure, silence, all combining into one recognizable experience. Tonight, imagine standing outside in the calm before a snowstorm. The wind is still, the sky has turned that soft silver grey. The world feels momentarily held, like something is about to happen, but gently, not urgently. And the air feels like snow, even before it falls, even before it touches your skin. Your body knows, your breath knows, and in that knowing, there is comfort. Because sometimes the atmosphere speaks softly, and we can listen. Even the biggest snowfalls can feel quiet in memory, while some winter storms leave behind impressive numbers, measured in inches, in hours, in maps of coverage. They can still live gently in our minds, remembered not as chaos, but as calm. Tonight, we'll revisit a few of the world's most notable snowfalls, not through urgency or alarm, but through a lens of wonder, stillness, and the way snow shapes not just landscapes, but stories. Let's begin in Washington, D.C. in 1922, during what became known as the Knickerbocker Storm. It began with a slow drift of flakes, gentle at first, but over the course of 2 days, it laid down nearly 3 feet of snow. The city came to a hush. Streetcars stopped. Steps disappeared. Trees bowed under the weight. And while the storm itself was powerful, what remains in the quiet corners of history are photographs of still porches, children wrapped in scarves, and rooftops heavy with white, soft blankets resting over brick and stone. Travel now to Japan, in the mountain town of Tsukayama, which holds one of the world records for snowfall in a single season. In the winter of 1927, over 100 inches of snow were recorded. That's more than 90 feet, layer upon layer of powdery snow accumulating over months. Yet locals remember it not in urgency, but in rhythm. Daily life continued. Paths were cleared, homes adjusted. Snow became not an interruption, but a companion. Then there's Syracuse, New York, often nicknamed the snowiest big city in America. One storm in 1993, part of a widespread event known as the Storm of the Century, blanketed the city in over 40 inches of snow. But ask residents what they remember most, and they'll often mention the silence, how the usual city sounds faded, how everything paused, how neighbors helped clear sidewalks together, slowly and without rush. These historic snowfalls are notable not just for their scale, but for their atmosphere. Even in record-setting events, snow remains slow. It falls one flake at a time. It builds gently over hours and days, turning familiar places into white, sleepy worlds. Schools close, not in panic, but in permission to rest. Roads fall silent. Windows frame winter's artwork, and people pause to simply watch it continue. And then there are personal snowfalls, the ones not recorded in charts, but remembered in hearts. The first snow of a childhood winter, a quiet evening walk as flakes gathered on eyelashes, the way a town square looked under lamplight after a long night of flurries. Tonight, we remember that even history's biggest storms had quiet moments. Moments when the world slowed. Moments when snow didn't overwhelm, it simply arrived and stayed, gently, but the shape of each snowflake, the weight, the design, the texture, changes with the quiet hand of humidity. Tonight, let's gently observe how moisture in the air helps shape every snowflake, crafting each one as a unique expression of the atmosphere. Humidity refers to the amount of water vapor in the air. And while we often associate high humidity with warm, muggy days, it plays an equally important role in winter, especially in the formation of snow. When snowflakes form in clouds, they grow by collecting water vapor. The more moisture available, the more material the crystal has to build with. High humidity allows for faster growth, and often leads to larger, heavier flakes. These snowflakes may appear as wide, star-like structures, or they may clump together in fluffy clusters as they fall. You've likely seen these on days when snow falls thick and fast, flakes the size of feathers, drifting lazily but with a satisfying fullness. These flakes catch on coats. They blanket everything quickly. They're rich in water and often lead to snow that packs easily, perfect for snowballs and soft sculpting. On the other hand, when humidity is low, snowflakes grow more slowly. The crystals remain smaller and more defined, with sharp arms and intricate details. These flakes fall faster and are less likely to clump. The result is powder snow, light, dry, and airy. It squeaks underfoot. It brushes off easily. It creates the soft, floating flurries you might see in alpine regions, or during the coldest parts of winter. This is why two snowfalls can feel so different. One might fall thick and heavy, dampening the world with a quiet weight. The other might fall like ash, delicate and dry, barely leaving a trace until it begins to gather in corners and hollows. Humidity shapes the behavior of snow as well. Heavier, wetter snow sticks to tree branches and power lines. Lighter snow blows easily in the wind, creating drifts and soft waves. Snowfall intensity, accumulation, and texture all reflect the balance between temperature and moisture in the air. Even the appearance of snow under light changes with humidity. Wet snow reflects more directly, sparkling under lamps. Dry snow scatters light more evenly, creating a velvety matte glow across the ground. All of this, how snow looks, feels, falls, is quietly choreographed by humidity. It doesn't shout, it doesn't rush, it simply whispers through the flake, guiding its formation with invisible hands. Tonight, imagine a snowflake's journey through a humid cloud. It reaches outward, it thickens, it softens. Now imagine that same flake in dry air. It remains crisp, sharp, it falls quickly and alone. Both are beautiful, both are snow, and both remind us that the atmosphere creates not just precipitation, but art. Snow may fall in silence, but from far above, it leaves a visible trace, soft, shimmering, and vast. Tonight, let's float higher than clouds, beyond weather balloons and mountaintops, and drift into orbit, to view snowfall from space. High above Earth, satellites glide in quiet loops, hundreds of miles above the surface, circling the globe every hour. From these altitudes, snow-covered landscapes appear not as storms or flurries, but as glowing blankets of white, gently draped across continents. To the human eye, snow seen from space is breathtaking. In true color satellite imagery, fresh snow cover reflects light so vividly, it appears as pale silver or pearl white, even under clouds. It gathers along mountain ranges, clings to river valleys, and outlines shorelines with luminous edges. But satellites don't just capture beauty, they observe with purpose. Instruments aboard weather satellites, such as those from NOAA or NASA, use multiple wavelengths, visible, infrared, and microwave, to detect snow. They can distinguish between clouds and snow cover, monitor how deeply snow accumulates, and even estimate its water content. This information helps scientists track the movement of winter storms, understand snowpack trends, and predict water availability in spring. From orbit, snowstorms themselves appear as spiraling cloud systems, soft-edged, slow-moving, and expansive. You can see where the snow is falling by identifying cold cloud tops and dense moisture bands. At night, infrared sensors help detect these patterns even without sunlight, while visible light sensors, like those on the Suomi NPP satellite, can capture moonlit snow scenes glowing faintly in the dark. It's a perspective that makes even the most localized flurry feel part of something larger. A snow-covered farm field in the Midwest, a rooftop in Tokyo, mountain pass in Norway. Each of these becomes part of a wider story, woven into the fabric of the Earth's frozen tapestry. But what's perhaps most beautiful is how quiet snow looks from space. There are no plows, no footprints, no noise, just whiteness spreading slowly, soft outlines of forests, rivers like dark veins cutting through bright fields. Snow, as seen from above, reminds us of snow's true reach, not as a momentary event, but as a presence. a participant in climate, in rhythm, in Earth's breath. Tonight, close your eyes and imagine yourself far above the planet. You see the curve of the Earth. You watch clouds swirl, and beneath them, snow glows. A continent hushed in white. A world tucked in. From orbit, even winter feels peaceful. There is a kind of night that doesn't feel dark. Not because of city lights, not because of a full moon, but because of snow. Tonight, we'll rest in the vision of a white night, a winter moment when snowfall continues after sundown, covering the world in brightness, softness, and deep, peaceful calm. A white night isn't about insomnia or wakefulness. It's not a restless phrase. It's a quiet phenomenon, a blend of reflection, silence, and snowfall that transforms the atmosphere. When fresh snow covers the ground, it creates a natural reflector. Even the faintest light, starlight, moonlight, the glow from a distant window, bounces off the snowy surface and spreads through the night air. Instead of disappearing into shadow, the light expands, gently filling spaces. Add to that a softly falling snow, flakes descending in a slow, uninterrupted rhythm, and the world becomes wrapped in a kind of glowing stillness. No footsteps, no breeze, just a quiet continuum. These nights can happen anywhere. In forests, where branches collect thick layers of snow and starlight filters through. In cities, where street lamps cast halos on snowy sidewalks and time feels paused. In wide open fields, where the ground glows faintly blue and the horizon vanishes into softness. The snow continues to fall, and somehow, though the clock moves forward, time itself feels slower. This is the white night. It's not loud or dramatic. It doesn't call for attention. It simply is. A moment where everything aligns. Cold air, quiet skies, fresh snow, gentle light, and creates a space where even dreams seem more vivid. Children sleep through it. Animals nestle beneath it. Roads fall silent. And the world, just for a while, feels not asleep, but deeply resting. Meteorologically, these nights occur during calm conditions, often after a storm has passed, or between pressure systems. Winds are minimal, skies are partially open, and snowfall is light, steady, and continuous. No sharp flakes, no bitter gusts, only the steady whisper of snow. And under that whisper, warmth. Not physical warmth, perhaps, but emotional warmth. The kind that comes from being inside, looking out, from watching the flakes fall and knowing that the world is safe, that the night is long enough to hold everything. Tonight, imagine yourself in that moment. The lights are dim, the room is quiet. Outside your window, snow is still falling. You can't see the stars clearly, but the sky glows faintly, the ground sparkles, and the night feels soft. A white night, not a sleepless night, but a snowlit one. A quiet pause in the rhythm of winter, a moment between hours, where snow continues, and time gently drifts. A snowflake's fall may be quiet, but its journey doesn't end when it reaches the ground. After it lands, on a rooftop, a treetop, a scarf, or a frozen field, it continues to change, slowly, silently, becoming part of something else. Tonight, let's follow the soft story of a snowflake after it touches down, and witness the final chapters in its delicate life. When a snowflake lands, it is still cold, still perfect, still whole. But the moment it settles, it begins to feel the influence of the world beneath it, of warmth, of pressure, of sunlight and time. If it falls on soft snow, it may nestle gently into the surface, joining a growing snowpack, becoming part of a quiet, layered landscape. Its sharp edges may round, its intricate branches may soften. Other flakes will land nearby, and together they will press into one another, adjusting slightly with each breeze or subtle shift. If it falls on a warmer surface, it may begin to melt almost immediately. Just a single degree above freezing is enough. The flake becomes a droplet. The droplet begins to slide. And just like that, the crystal that traveled so far through the sky has returned to liquid. Sometimes the snowflake isn't alone. It's part of a flurry, a storm, a steady drift of snowfall. In these cases, the snow builds layer by layer. The lower flakes, those that landed first, begin to compress under the weight of new arrivals. Their structure breaks down, their shapes change. Over time, they become grains, small, rounded bits of ice, no longer recognizable as flakes, but still very much snow. Beneath the surface, the snowflake continues its quiet transformation. During the day, sunlight may warm the top layer of snow, causing it to partially melt. At night, when temperatures fall again, that meltwater can refreeze. This process, called melt-freeze metamorphism, causes snow to harden and crystallize further. The flake, now long gone in form, contributes to a complex structure, part insulation, part memory, part mirror of time. If the weather warms steadily, the snow will begin to melt completely. Water drips from eaves and pine needles. Icicles form, the snowpack shrinks, and somewhere deep within that process, the snowflake quietly returns to the cycle of water. It may trickle into soil. It may run off into a stream. It may be absorbed by roots or evaporate back into the sky. Its life continues, invisibly, from flake to snow to melt to mist. The life of a snowflake is not just about the fall. It is about transition. It is about becoming. And it is always, always quiet. Tonight, picture a single flake landing softly on a stone. It rests there, then melts. A droplet clings to the edge, then falls. It disappears from view, but not from the world. It has simply changed form, and in doing so, it begins again. There is a special kind of snowfall that happens in the woods, where wind doesn't rush and light filters through in ribbons, where trees catch the snow before it reaches the ground, reshaping its descent, where everything feels older, softer, slower. Tonight, we'll nestle into this forested stillness and listen to how snow behaves among trees. In an open field, snow falls freely. Flakes drift down without interruption, covering every surface evenly. But in a forest, especially a pine or spruce woodland, snowfall meets texture. The needles of evergreen branches catch the flakes like quiet nets. Snow gathers on limbs, mounds gently in tufts, and hangs until the weight is just enough to fall again. This creates a unique rhythm, 2 snowfalls, the first from the sky, the second from the trees. You might hear it while walking in the woods after a storm, a soft whomp as snow drops from a branch, then silence, then another, and all the while, the air is quieter than usual. The canopy of trees muffles outside sound. Bark and branches absorb footsteps. The ground, uneven with roots and rocks, holds snow in strange, beautiful shapes, draped over stumps, curled around trunks, pooled in the hollows between roots. Light behaves differently here too. Moonlight filters through the canopy in silvery shards, casting slow-moving shadows across the snow. The undergrowth glows faintly, dappled in soft light. During the day, if the sun shines through, each droplet on each pine needle becomes a prism. Forested snowfall also changes accumulation. Snow doesn't pile as deeply beneath thick branches. Some areas remain bare, while others build up in ridges, shaped by falling clusters from above. These patterns Patches of deep snow beside clear ground tell a story of shelter and wait and pause. And then there is the scent. Snow in a forest carries the smell of pine, of bark, of cold air on moss. It's not strong, but it lingers, a clean, earthy freshness, as if the snow is gently wrapping every scent in silk and releasing it slowly. Forest animals move differently in snow too. Their tracks are clearer, their presence is quieter. You might see tiny prints across a drift, a rabbit's path between bushes, the mark of wings where an owl lifted off, and above it all, the snow continues to fall, one flake at a time, weaving through branches, landing where it can. Tonight, imagine yourself deep in the woods, snow falling through pine needles, a branch bending, then releasing its weight in a puff of snow dust. The ground beneath you soft and uneven. No roads, no rooftops, no rush, just snowfall in a forest, where the world is made of green and white, and stillness. When you think of deserts, you might picture heat, dryness, endless sand beneath a shimmering sky. But even the most arid landscapes can host snowfall. Yes, it snows in deserts too, and when it does, it arrives not with drama, but with stillness, softness, and wonder. Tonight, we'll travel quietly to the high desert plateaus, the cool basins, and the sleeping mesas, where snow falls in the most unexpected of places. Deserts aren't defined by heat, but by lack of moisture. They're places that receive very little annual precipitation. Some are hot, like the Sahara or Mojave. Others are cold, like the Gobi or the Patagonian steppe. And some, like the deserts of the American Southwest, sit at high elevations, where temperatures dip low on winter nights. In these high deserts, snowfall is not only possible, it's gently regular. Places like New Mexico, Utah, Arizona, and northern Nevada often experience light snow during the winter months. Even Las Vegas, surrounded by desert terrain, has seen snowfall. Rare, but memorable. When snow falls in the desert, it meets a land of contrast. Red rock dusted in white, cacti crowned with crystals, dunes striped with the quiet shading of morning flurries. It doesn't usually fall heavily. Deserts lack the deep atmospheric moisture needed for prolonged storms. But snow arrives in short, beautiful bursts, flurries that cling to stone for an hour or two before melting beneath a returning sun. The desert, for a time, becomes quiet in a new way. Wind stills, wildlife pauses, and the muted tones of sand and sage are softened under a thin veil of snow. Even the vast sky above seems lower, more tender. And while the snowfall may not last long, its effects linger. Cold desert nights allow snow to remain through morning, creating a silvered landscape bathed in soft dawn light. The snow highlights the sculpted curves of canyons, the ridges of plateaus, the branches of dry juniper trees. It outlines the terrain with light instead of shadow. Meteorologically, desert snowfall is often caused by cold fronts sweeping through elevated regions, bringing in just enough moisture to generate brief snow showers. Because the air is so dry, much of the snow sublimates, turning directly to vapor before reaching the ground. But when conditions are just right, the flakes survive their descent, and when they do, the result feels like a secret, like a gift wrapped in silence, like winter whispering to a place that doesn't expect it. Tonight, picture a quiet desert valley. The earth is still. A few snowflakes fall, not many, just enough. They gather on a cactus arm. They rest on ancient stone. And for a moment, the desert dreams in white. Have you ever looked up at the sky and seen no clouds? And yet, a snowflake drifts past your window. It seems impossible, but it happens. Tonight, we'll explore one of winter's quietest illusions, how snow can fall from a sky that appears completely clear. The phenomenon is often called snow from a clear sky, or snow, flurries from blue sky, and while rare, it's real. Meteorologists call it diamond dust, or clear sky snow. So, how can snow fall when clouds are nowhere to be seen? Let's float gently through the explanation. In most cases, this kind of snow comes from very thin, high clouds, so faint and diffuse they're almost invisible from the ground. These clouds are typically made of ice crystals and don't appear as solid grey masses like storm clouds. Instead, they're wisps, veils, so transparent that they let blue sky and sunlight shine through. These faint clouds may exist in the upper atmosphere, quietly releasing ice crystals downward. The crystals are small, often called diamond dust, and they drift more than fall, sometimes barely noticeable unless caught in a beam of light. In cold regions, especially near the poles, in high elevation basins, or during Arctic air outbreaks, the air near the surface can be extremely cold and still. In these conditions, water vapor near the ground can undergo deposition, turning directly into tiny ice crystals. These crystals then float through the air, shimmering, glittering, falling from nothing. No clouds, no breeze, just snow, from nowhere. Another possible explanation is that snowflakes formed in a distant cloud layer, perhaps miles away, and drifted long and low across the sky, falling gently into an area where the sky has already cleared. These snow showers can be remnants of a dissipating weather system. The storm has passed, the clouds have parted, but a few final flakes remain in the air, completing their long descent. To someone on the ground, it feels like magic. You glance up, blue sky above, bright sun, no sign of a storm, and yet the snow continues. There's no urgency, no wind, just a hush. It's one of the rarest and most beautiful types of snowfall. One that doesn't announce itself. One that doesn't need thunder or clouds. Just cold, just calm, just time. Tonight, imagine yourself in an open space, perhaps a park or a snow-covered field. The sky is clear, the air is still, and then a sparkle, a shimmer, a snowflake drifting across your line of sight. You blink, you smile, and you realize it's snowing. From a sky that forgot how to hold clouds. A quiet reminder that not all snowfall comes from storms. Sometimes it comes from silence, past ship decks and swaying waves. And when it does, the experience is surreal, quiet, misty, and dreamlike. Tonight, we'll set sail into the rarely seen world of snow at sea, where winter brushes the open water with the same gentle hand it uses on rooftops and fields. Maritime snowfall is less common than land-based snowfall, but it happens, especially in cold ocean regions and high latitudes, where sea temperatures dip low enough for snow to survive the journey to the surface. Areas near the Arctic Circle, the North Atlantic, the Bering Sea, and even parts of the Southern Ocean can experience snow over open water. These snowfalls are different. They don't accumulate on the sea. There's no blanketed surface, no snowpack, no crunch underfoot. Instead, the flakes land on waves and dissolve, vanishing into the dark water within seconds. But for those sailing through, the effect is unforgettable. Snowfall at sea feels almost suspended. The soundscape is entirely different. No trees, no buildings, just wind, water, and flakes that drift through fog and cloud, often illuminated by a soft grey sky, or the pale yellow glow of ship lights. It is a kind of floating silence. Snow on the ocean is often linked to sea effect snowfall, similar to lake effect snow on land. When cold air moves across relatively warmer sea surfaces, it picks up moisture. This moisture rises into the cold air above, forming narrow clouds that release snow downwind. These maritime snowbands are often localized, impacting ships, coastal islands, or peninsulas in delicate drifting patterns. There are also snowfalls born of polar systems, slow-moving, cold core lows that produce long-lasting, light snow over icy waters and frozen seas. These systems don't bring blizzards. They bring subtlety, persistence, snow that falls for hours with barely a sound. Imagine standing on the deck of a ship in the middle of the ocean. All around you, water stretches to the horizon, deep, dark, endless. And from above, snow begins to fall. No rush, no storm, just soft flakes landing on your coat, your hands, your hair, melting quietly. The waves rise and fall, indifferent to the snow. The sky hangs low, grey and gentle, and time itself seems to pause. There is no accumulation, but there is presence. A snowfall without footprint, a winter with no path. Just the dance of flakes on waves. And when the snow ends, it leaves no trace, only the memory of a moment when sea and sky touched gently, one flake at a time. Some snowfalls rush in, others barely whisper, but all snow can be measured. Tonight, let's explore the gentle science of snowfall rates, how we observe and describe the pace at which snow falls, using soft language and soft tools. A snowfall's rate is simply how much snow accumulates over a certain period of time, usually measured in inches per hour or millimeters per hour, depending on the region. But this measurement isn't just about numbers. It helps meteorologists describe the feel of a snowfall. Is it a light dusting, a steady coat, a deep, slow build? Let's start with the gentlest. Trace snowfall. This is when snow is falling, but not enough to measure. It doesn't accumulate, just a few flakes dancing in the air. You might see them catch in a beam of light or gather in the corners of a windshield, but they vanish as quickly as they arrive. Next comes light snow, generally defined as up to 1 millimeter per hour, or less than 0.1 inch per hour. This is the softest kind of accumulation. It doesn't change the landscape quickly. It takes hours to leave a gentle blanket, and often leaves time to pause, to watch, to breathe. Then we have moderate snow falling at 1 to 2.5 millimeters per hour, or around 0.1 to 0.3 inches per hour. This type is steady, visible, and soothing. Sidewalks begin to fade, branches fill, windows frost. It's the kind of snow you might watch from inside, feeling the world grow quieter, inch by inch. Heavy snow is defined as more than 2.5 millimeters per hour, or more than 0.3 inches per hour. But even this doesn't mean chaos, not in our bedtime world. In calm conditions, even heavy snow can fall silently, a curtain of white, building softly on everything it touches. Meteorologists use snow gauges, laser sensors, and even dual polarization radar to estimate snowfall rates in real time. But they also use visual cues, how far you can see, how quickly surfaces change, and how much is left behind. There are snowfall rate terms that feel almost poetic. Snow showers, intermittent bursts of snow, varying in intensity. Flurries, very light snow, falling irregularly. Steady snow, a consistent, unchanging pace. Burst snow, a short-lived increase in intensity, like a snow thought passing by. Snowfall rate is not about drama. It's about rhythm, the rhythm of the sky, the pace of stillness. And while we can describe it with numbers, We can also describe it with feeling, the kind of snow that lingers, the kind that paints, the kind that erases. Tonight, imagine snowfall at 1 inch per hour, flakes drifting steadily, but not rushing, a soft brushing of rooftops, a slow build-up on branches. No wind, no noise, just presence, because sometimes the gentlest measurements are the ones that fall the slowest and leave behind the most quiet. Snow doesn't just fall, it shines, it glows, and sometimes it bends the light. Tonight, we'll drift into the quiet optics of snowfall, those beautiful, subtle moments when snow doesn't only reflect light, it shapes it. Hollows, sundogs, glows, all conjured by tiny frozen crystals drifting through the cold sky. When we think of snow, we often picture it on the ground, white, soft and glowing under a street lamp or moon. But even before snowflakes settle, they interact with light in remarkable ways, especially when suspended in the air. The key lies in the structure of the crystals. Snowflakes are made of ice, but not just any ice. Their hexagonal symmetry, their flat faces and pointed arms make them miniature prisms, shaped not for melting, but for bending light. As light enters one side of a snow crystal, it slows slightly, passing from air into solid. This change in speed causes the light to bend or refract, just like it does through a glass of water or a prism. If the crystal is oriented just right, and the sky is full of others like it, this gentle refraction becomes visible in the sky. One of the most magical results is the 22-degree halo, a faint, circular ring of light surrounding the sun or moon, created by millions of tiny ice crystals in the upper atmosphere. Each crystal bends the light just a little, 22 degrees to be exact, and together they form a glowing circle of pale light. It's not sharp, not bright, but unmistakably present. Then there are sundogs, small rainbow-like patches of light that appear to the left and right of the sun, often during bitterly cold mornings. These too are created by the refraction of light through plate-shaped ice crystals, gently falling in flat orientations through the sky. They shimmer, they hover, and they appear when we least expect them. Small gifts from the atmosphere. Even snow on the ground shapes light. Fresh snow scatters sunlight in all directions, creating a diffuse, even glow. At night, this soft scattering gives snowy landscapes their blue or silver tint under moonlight. During sunrise or sunset, snow reflects warm tones, rosy, amber, golden, painting the landscape in quiet flame. And during light snowfalls, when flakes drift slowly through the beam of a street lamp, the light becomes textured, not just illumination, but presence. Flakes catch the glow and scatter it. They shimmer, sparkle, drift through cones of light like falling stars. Sometimes, in the presence of moisture and cold air, snow can even create light pillars, vertical columns of reflected light that seem to stretch into the sky. These occur when flat ice crystals near the ground reflect streetlights or other bright sources, stacking their reflections upward in a silent tower of shimmer. All of this, from frozen air, from softness, from shape. Tonight, imagine yourself walking beneath a pale winter sky. The sun is low, the air is still, and then you see it, a faint ring around the sun, a quiet echo of light. You stop, you breathe, and you realize snow isn't just white. It is a prism, a lens, a painter of sky. Snow doesn't disappear in an instant. It doesn't shout when it leaves. Instead, it melts softly, layer by layer, flake by flake, slipping back into the earth like a whispered goodbye. Tonight, we'll follow the gentle process of snowmelt. The final act in this life of snowfall, and perhaps the quietest. As temperatures rise, slowly, day by day, the snow begins to change. The top layer softens under the sun's touch, not dramatically, but tenderly. The flakes that once clung tightly to one another begin to loosen, reshape, and surrender. At first, the change is almost invisible. A hint of gloss on the surface, a faint sag in the snowpack. Then, tiny droplets begin to form, glittering along the edges of roofs and pine needles, gathering in corners, slipping into the shadows. The sound of snowmelt is one of winter's softest melodies. It's not a trickle, like rain. It's not a rush, like a stream. It's a drip, then a pause, then another. A rhythm you can hear only if you stop moving and truly listen. Drip, drip, drip. Each droplet carries the memory of a snowflake. Meltwater seeps down into the snowpack, reaching the layers below, warming them in turn. In some places, water flows into hidden channels within the snow, meltwater pathways that wind through the frozen structure like miniature rivers. These channels carry warmth deeper into the pack, accelerating the transformation. And as the days pass, the snow loses its shape. It shrinks, it sags. What was once a sharp, crisp edge becomes round and slushy. Crystals collapse, grains coarsen. The snow no longer sparkles as it once did, but it still holds its grace. Eventually, the melt reaches the soil. There, it's welcomed. It nourishes roots sleeping in the dark. It fills aquifers, replenishes streams, and prepares the ground for spring. This is the quiet generosity of snow, how it gives even as it leaves. The process isn't always steady. Warm days are followed by cold nights. Snow may melt a little, then refreeze. Icicles form, then fall. A patch of grass appears, only to vanish again beneath a light dusting. But over time, the direction is clear. Snow gives way, not in anger, not in haste, but in understanding. Because snow was never meant to last. It was meant to fall, to rest, to nourish, to fade. Tonight, imagine sitting by a window on the first truly warm day of winter's end. Outside, the snow is soft and shallow. You can hear it, faint droplets falling from eaves, pattering gently onto stone. Not rushing, not pleading, just whispering. The final breath of a snowfall becoming water and returning home. Every snowfall has an end. Even the most delicate flurry, the most persistent storm, the most gentle drifting, it all comes to rest, eventually. And somewhere within that fading, the very last flake falls. Tonight, let's pause with that final moment, the closing breath of a snowfall. It doesn't arrive with notice. There is no announcement. Often, we only realize its ending when we look again and find the air is still, the sky has lightened, the flakes have slowed to a stop. Before that, though, there's a quiet shift. The snow becomes lighter, less frequent. A once steady curtain turns into a wandering flake here and there. You watch the last few drift downward, lazy, slow, suspended. Meteorologically, this ending happens when the moisture supply runs out, or when temperatures aloft begin to rise, turning potential snow into rain, or even nothing at all. But it never feels abrupt. Snow rarely stops with a jolt. It tapers, it exhales, clouds lift, the air brightens, and slowly the snowfall becomes memory. Look closely during this time and you'll see the transition. Flakes that melt before reaching the ground. Snow that no longer accumulates. Tiny spaces of exposed earth or stone appearing here and there, like the land remembering itself again. There is something deeply peaceful about the end of a snowfall. No thunder, no stormy crescendo. just a gradual, silent conclusion, as if the sky is tucking in its softest sheets, folding them back into the clouds for another night. The final flake often feels symbolic. It marks a turning, a shift back toward normalcy, toward clear skies, toward sound returning, toward the world waking up beneath its snowy hush. But for now, stay with that flake, the last one. Watch it tumble slowly through the air, dancing a little in a breeze. It may catch a ray of moonlight. It may swirl gently before landing, melting the instant it touches the warm sleeve of your coat. And then, stillness, a world wrapped in white, a sky returning to itself, a story closed without ever needing a final word. The final flake isn't an end, it's a pause, a soft promise that snow will return again. When the air is right, when the sky is ready, when we're ready to dream again. To close our journey tonight, let's linger with a quiet question. Why does snowfall feel like magic? What is it about those drifting flakes, those silent, soft transformations that touches something deep within us? It's not just the science, though the science is wondrous. It's not just the silence, though the silence is profound. It's something more, something felt. Snowfall has the power to change the most familiar places. A street you've walked 1,000 times becomes new again. A backyard becomes a winter painting. Footsteps vanish, sounds hush, lights soften. It's as though the world has paused, not stopped, but exhaled. Meteorologically, snowfall is simply frozen water vapor, condensed around a nucleus and shaped by temperature and humidity. But experientially, it's enchantment. It's the slowing of time, the softening of space, the transformation of everything known into something dreamlike. Children often sense it first. The thrill of watching flakes from a window, the giddy hush of an unexpected snow day, the pure joy of catching a flake on the tongue, only to have it melt away like a secret. But even as adults, snowfall returns us to wonder. It reminds us how quiet can be beautiful, how the ordinary can become otherworldly, how something as simple as ice can fall from the sky and make us stop, breathe and watch. Some say it's the rarity of snow, how it doesn't happen every day and sometimes not at all. Others say it's the softness, the lack of threat, the way it gently lays itself across the world without demanding anything in return. But perhaps it's also that snow doesn't announce itself. It arrives humbly, quietly, flake by flake, covering rooftops, coating trees, turning the world into a slow-moving lullaby. And when you step outside during a snowfall, there's no rush. You walk slower, you look upward more, you feel the cold on your cheeks and the quiet in your bones. That is the magic. It doesn't just happen in the sky, it happens in you. Tonight, as we reach the end of our snowfall journey, may you carry that stillness with you. May your breath slow like drifting flakes. May your thoughts quiet like a winter forest. And may the snow, real or imagined, hold you gently as you sleep. Because magic doesn't always sparkle. Sometimes it falls silently from the sky. And as our gentle journey through snowfall comes to a close, I hope you found a hush within yourself, mirroring the calm of the falling snow. May these quiet skies stay with you, long after the last flake has touched the ground, long after the clouds have drifted on. We've wandered through crystal structures and sleeping forests, through silent cities, moonlit fields, and drifting skies. Together, we've traced the life of a snowflake from its invisible beginning in the cold heights of the sky, all the way to its soft, whispering end on earth. If these snowy moments brought you peace, If you felt even a little more rested, more settled, more at ease, you're always welcome to return. Feel free to like or subscribe, but only if it feels gentle and light for you. For now, let the night wrap around you. Let your breath drift like snowflakes. Let your thoughts melt into softness. Let your body settle beneath a quiet sky. Snuggle in. You've earned this stillness. You are safe. You are warm. You are home in the hush of night. Good night. Peaceful dreams. Calm skies to you.